We're going to start here just at the top with graphing. Okay, so making sure we know what the graph of the parent functions look like. So for your log parent function, remember we have red. We have a vertical asymptote along the y-axis. Okay, so I like to start with my asymptote. Okay, because again, this is like your parent function. There is no transformations taking place. Okay, we talked about how your log function has a an x-intercept at 1, because if you take the log of 1, it doesn't matter what the base is, log of 1 equals 0. So 1, 0 is a point on there. We also talked about how if your argument of your log, that's what you're taking the log of, matches the base of the log, that log base b of b is always going to equal 1. Okay, so here, what is our base? If there's no base written, what's it understood to be? A 10. So this is a log base 10. So if I input a 10 for x in the argument, log base 10 of 10 will equal 1. So if I input a 10, I get an output of 1. So there's going to be a point at 10, 1. Now, if this wasn't any other base, like if it was a base 2, there would be a point at 2, 1. If it was a base 5, there'd be a point at 5, 1. Do y'all get that? So that's how you get your x-intercept, and then you get your other point based on what your base is. Okay, and your asymptote and those 2 points, those are enough for us to sketch the curve. That was terribly drawn. Let me try that again. So there we have our log of x. That's our common log. Okay, so that's our general shape. Now remember your transformation rules. That'll shift around, up, down, left, right, stretch, compress, reflect, all that jazz, same as any other function. I don't know why it says honors only for the natural log. We're going to go ahead and do it because we've graphed natural logs, so we should be able to graph this one as well. Okay, so I'm going to start with that same asymptote. Now, what is the understood base of a natural log? E. Okay, but it doesn't matter what the base is for the x-intercept. Okay, so the natural log of 1 is also 0. So the x-intercept doesn't change because the base changed. Okay, now that second point that we plot is going to change, because for this to equal 1, our input would have to be E, right? Because it would have to match the base. So you do kind of have to remember approximately what E is. Does anybody remember? It's a little less. It's about 2.718. If you don't remember, guess what? You get Desmos. You could literally just go plug this in and see what the graph looks like, or go plug in natural log of E and see what it E and see what it is. It's about 2.7. So that means we'll have a point at about 2.71. So approximately there. Now, whichever the common, I'm going to put the name here. This is your common log, an understood base 10. And this is your natural log, which is an understood base E. For both of these, and for any other log with any other base, okay, any other, as long as no transformations are taking place, what is the domain? How far left to right do these graphs go? Yeah, this asymptote is the edge, okay? It's the borderline. You're not passing it, right? So it's not going to go past 0, okay? This asymptote is at 0 to start with, no matter what the base is. Now, if you start to translate the graph, if you shift the graph left or right with your transformation rules, yes, that asymptote's going to move, which is going to move our domain. Okay, but for these basic functions with no transformations, it's 0 to infinity, left to right. Now, when you write that in interval notation, you do not include infinity ever. It's always a parenthesis. And you don't include 0 in this case because it's an asymptote. So you would have parentheses around the 0 and the infinity. Okay, so 0 to infinity. You know what? I'm going to write this one. It's the same, but you could write it in inequality notation. Who remembers what that would be in inequality notation? 0 to infinity means everything greater than 0, doesn't it? So that's what you would write. And we're talking about domains, so these are x's. So x is everything greater than 0. That's how you could write it as well. Now, what about the range for both of these? Yeah, all reals are negative infinity to positive infinity. The graph, we're talking about y values. It goes down forever, so it includes all negative y values down to negative infinity. And as it's going right, it is not completely flattening out. There's no horizontal asymptote on these logs. So it is increasing as it goes to the right. So it's going up forever as well. So you can write that as negative infinity to positive infinity in interval notation. Again, both sides parentheses. Or you could use the all real number symbol. You need to know both in case it's a multiple choice question and it's written one way or the other. You'll feel okay about those parent functions, what they start out as? The asymptote, we drew it. It is at x equals 0. Remember, a vertical line crosses the x-axis, so it's x equals. And in this case, it's x equals 0. Remember your asymptote, your vertical asymptote for logs will always be at x equals h, whatever your h value is. So in these cases, there's nothing inside the log with the x, right, in parentheses. So h is a 0. All right. Now let's look at transformation. So I'll go ahead and write out where everything would show up in a transformation of a log. So you'd have a in front being multiplied times the log, whatever the base is, that doesn't matter. But then you'd have x minus h inside the argument of the log and then plus k on the outside. Okay, so in number 3, what is my h value? It's just 2. Remember, x minus h. So since it's a minus in there, the h is just the positive 2. So that right there tells me where my vertical asymptote's going to be, because remember, h is a horizontal shift. So this is a horizontal shift to the right 2, which means I have a vertical asymptote at x equals 2. So I'll go ahead and sketch that. All right, any other transformations on this one? A is the understood 1, nothing multiplied in front, so no stretch or compression, no reflection. K, there's nothing added on the outside, so K is an understood 0, so no vertical shift. So the only change is right 2. So what was my x-intercept at 1 is now at 3, because I went to the right 2. Now, this is a base 3 log. So originally there would have been a point at 3, 1, wouldn't there? Remember how we talked about whatever the base is, if our input matches it, the output's going to be 1? So there would have been a point at 3, 1, but this is shifted right 2. So I can go to 3, 1 and then shift right 2. Okay, or I can, another way to think of that, if that confuses you, is say, okay, what would make this argument 3 so that it matches the base? And you could say, that'd be a 5, 5 minus 2. So that means if I input a 5, I'm going to get an output of 1. And so you can see that's where I put the point, was at 5, 1. Or you get Desmos. Use it. Write this in Desmos and look at the graph. Okay, to get your points to help you sketch the graph. In number 4, what is H? Now, is that H, is that, sorry, is that 3 in parentheses or outside parentheses? Yeah, there are no parentheses, so it's definitely not inside them. So that is not H. Okay, this is what gets confusing sometimes. You see that +3 and think it's on the X, but if it was with the X, if it was an H value, it would have parentheses around it. So the H is actually 0. There is no H because there's no parentheses. So my asymptote, I know, is still going to be at 0. Now, the A value is an understood 1 again. There's no coefficient being multiplied out front, but the K value is the 3. So this graph is shifted up 3. Okay, so what is normally my x-intercept here is going to go up 3. 1, 2, 3. Now this is a base 2. So normally, if I input a 2, I would get a 1. Okay, there would normally be a point at 2, 1, but this is going to shift up 3. And that would make sense. If I plugged in a 2, log base 2 of 2 would be 1. 1 plus 3 is 4. So there's a point at 2, 4. You'll feel okay about that? You can get additional points. You can use Desmos for more, but a couple points is probably good. I'll put one more. I'll do 4 because 4 can be written as a base 2. It'd be 2 squared, so we want that to be 2, that'd be 5. So then I can sketch this curve like this. And again, you can use Desmos if you aren't quite grasping doing this by hand. Use Desmos. So far, so good? Domain of this one on the left. Our asymptote shifted, so our domain changed. It's not 0 to infinity anymore. It's what? Where's that asymptote? 2. So it's 2 to infinity. Still don't include it, still parentheses. Did the range change? Did how low to how high the graph goes? No, the range is going to stay unaffected. For all log functions, the range will be all real numbers. It doesn't matter what transformation takes place. The range is not going to change. You can go ahead and fill that in for this one. It's going to be all real numbers. We don't even have to look at it. We just have to know it's a log. Okay, we did say the asymptote here moved to 2. So it was at x equals 2. Here, the asymptote did not move, so it stayed at x equals 0, which means my domain would stay 0 to infinity. Still feeling good with graphs? All right. You know what? I'm going to stop that video there. That'll just be the front side, and we'll keep going, but I'm going to start it as a second video.